It's okay. What do you want to look at? Yes?
Number 32.
32. What we got? dy dx equals 2x plus 1, y plus 1, and y of negative 1 is 1. Okay, so we need to separate the variables. So 1 over y plus 1 dy equals 2x plus 1 dx. Antiderivative is the natural log of the absolute value of y plus 1 equals x squared plus x. So then raise both sides to e. So the absolute value of y plus 1 equals e to the x squared plus x times e to the c. Then we've got to get rid of the absolute value. So y plus 1 could be positive this, or y plus 1 could be negative this. So then we got to use this point to figure out c. So when I put a negative 1 in for x, I'm supposed to get 1 out.
I just want to let you know that the internet is down. In fact, is aware of it. It is on focus, and it will let you know when it's back up and running. Thank you.
So e to the c comes out to 2. Now let's try that here.
Sorry.
You okay? So then that doesn't work out so good because e to a power can't be negative. So that means the final answer is 2 e to the x squared plus x, and then I'm subtracting the 1 over, so minus 1. Which you might have gotten away with it because this one worked out. Or what do you mean by split it up? Yeah, so since in this case the negative doesn't work out, so you still could get the right answer if you didn't do that. But a different problem, maybe this was the one that works out, and so you got to remember that it splits up. Yes?
18.
Yeah, this one bugs everybody. Could rewrite it like that, right? This is t to the first power times t to the 1/2 power. So that's t to the 3/2. So then this is just the integral of t to the negative 3/2. And if you simplify first, then it's easy. This is just a weird one where you need to do some simplifying first before you attempt to take the antiderivative, because otherwise it's hard to find the antiderivative. Good. Yes, Corey?
35.
So you were having trouble taking the antiderivative of sine cubed, right? They told you to do this. So that's what those directions mean. I think so.
Yes.
Am I actually doing 35?
Yeah.
Okay, good. So they said you write a formula in the form of y equals integral a to x of f of t dt. So they were trying to give you a hint that they didn't actually want the antiderivative the explicit way. They wanted the antiderivative in this way.
So that's the final answer.
Well, we have to figure out what A and C are, but this is mainly the final answer.
I was kind of just confused on well.
Yeah, so that's what those directions meant. When they said find an equation y equals integral a to x of f of t dt, they meant this is fine to have in your final answer. Okay, but then y is 5 when x is 4. So we want to pick this to be 4 so that when we plug a 4 into there, this will come out to 0. And then we need the whole thing to come out to 5. So then if we put a 5 here, then when we plug a 4 in there, it'll come out to 5 like we want.
So C will 5.
Yes. So here's our y equals. So it meets both conditions. First of all, when you plug 4 in, you do get 5. And second of all, if you take the derivative of it, it's sine cubed of x. Yes? 21? So this is BC only, e to the 3x sine of x dx. Okay, so it's a UDV problem, so I'm going to have u equal e to the 3x and dv equal sine of x dx. So then the antiderivative of sine is negative cosine. And the derivative of this,
We are back up and running. Thank you.
if you use the board, you're running the whole time. Okay, does that make sense so far? Okay, so now we have this integral u times v minus the integral of v du. I should have put a dx here, technically. Yeah?
When you multiply the u and the v, the u part should be e to the 3x.
Yeah. Whew, that's weird. Thank you. We good? Okay, so then this isn't helpful. Well, I could change this to plus. This is not any better because it's just as bad. So now I'm going to do u dv again. So u equal 3e to the 3x. dv equals cosine of x. So now du is 9e to the 3x, and v is sine of x dx. Okay, so then recopying this. Now I've got my new u times my new v. Minus my v du. Then I can pull this 3 out. Another mistake somewhere. Thank you very much. This should be 9. Thank you. Is that right? Okay. This was my u times my v should have been 9. E to the 3x times sine of x. So then that should be a 9. Okay, so now it's still looking just as bad, except this matches up with that. So I can add that 9 of those to the other side, and then I would have 10 of those over there. So 10 of these integrals equals this. So then the answer is this divided by 10. So this is getting kind of lazy at this point, but the final answer is that divided by 10. All right, what's next? Yes, Braden. 51A. Okay, so on a half-life problem, so we got our time and our amount. Remember that you're allowed to make up the starting amount. So let's just say after 0, there's 100 grams of this stuff. So then the half-life is 2.645. So that means after 2.645 years, there's only going to be 50, or whatever it is, I don't know, years, months, minutes, seconds. So yeah, 2.645 years, it's going to be down to 50 grams. Okay, now also, since it's a half-life problem, you know that the growth rate is proportional to the amount. And we've separated the variables enough on this thing that we know that y is going to come out to e to the c times e to the kt. So then you plug this point in, and it's going to give you the e to the c. E to the 0 is 1. So now we know that y equals 100 e to the kt. So then we're going to plug this point in to find k.
What's K?
It's called the constant, the growth constant. It's just a number that varies from problem to problem that has to do with how quickly it grows. Yeah.
How did you get to the y equals 115 there?
Were you with me here?
Yeah.
Well, if e to the c is 100, then I just replace that with 100. Good. So now when I plug in 2.645 for t, I know I'm supposed to get 50 out. So then 1/2 equals e to the 2.645 k. Natural log of both sides. And then divide by 2.645. So then you got it. Are you okay with that?
So what would K equal?
It's just a number. It's called the growth constant.
Okay.
And it just means that, so in this case, I don't know what that number is. And on a different problem, it could be 0.3. It's not 0.3 in this problem. This just means that to find the slope, or to find the growth rate, you take that constant times the amount. So the growth rate at 100 would be that times 100. The growth rate at 50 would be that times 50.
Okay.
So the slope is proportional to the amount. And that k is the constant of proportionality that will get you the slope. All right, what's next? Yes, Kira. 55. Okay, so 55, you need some more information than what they give you on the page. You need this, the half-life of carbon-14 is 5,700 years. I looked that up. They have it in an example 3 pages earlier, so I guess they thought that you could look it up. To have you flip around and find it is silly. So there it is. So now it's a problem pretty much identical to this one. So, but I'm not willing to do it, but try it now with that information. And then if you still have a question, I'll answer it later. Yeah.
Oh, related to that question.
Yes.
So would K be the 90%? Because that's the.
Maybe I never got to the final answer, huh? On 51. Is that what you're saying?
So like, is K gonna be like the percent, sometimes gonna be the percentage they give?
No.
Okay.
I believe that some in the Blitzer pre-calculus book, they sometimes use K as the percent. And that's why it's in your head that might be the case. But that's not, it's right enough that I can't argue with the book, but it's not exactly right. It's right to 3 decimal places, is what I'm saying. Okay. As long as K is small. So yeah, you're just in the back of your head, you have a memory of Blitzer wanted you to put the percent in for K, which was fine for them, it's not accurate. Yes? So we're taking the antiderivative of 1 over x ln x dx. So you should have u be ln of x. So du is 1 over x dx. And so then dx is x du. So then this translates into 1 over x times u times x du. So then the x's cancel. So we really just have the integral of 1 over u du. So then that's the natural log of the absolute value of u. And then that's the natural log of the absolute value of the natural log of x plus c, just plugging back in what the u was. Sure, all it means is take the natural log of your number, you get another number, take the absolute value of it, now take the natural log again. Sure. That's like there's no reason you could do the square root of a number as well. It's just it's a command, so. But yes, does it look weird? Absolutely. Especially with the absolute values on it. They just flow. That's why blood gets going, they just come. Okay, anybody else?
I already got like the problem, I just don't really know how to do this slope field for number 25.
Sure. So, no, well, if someone else asks about it, sure, but I want to answer your specific question first. So this is 25, the slope field. And they give us that dy dx, sorry, this is 25. They give us, so you could go, of course, if you want. Corey, I'll just answer this for you. So for example, at the point 1, 2. If I want to know the slope there, I just have to put a 1 in here.
Okay, I didn't know because, okay, so I solved it for y, and then I was thinking like the slope field had to do with something with.
No, the slope field has something to do with the slope
Yeah,
equation.
now.
So you just plug 1 into that, get a number, And whatever it is, do your little tick mark that has that slope.
All right.
Good. And the other thing that's kind of confusing is there's not a y in this.
Yeah.
So you don't do anything with the 2. There's some slope field equations that have x's and y's, and then you have to plug both of them in. Good.